Okay, so your bearings question. So Ben sails his boat from a port P to a lighthouse L. First thing you're asked to do is measure and write down the bearing of L from P. Okay, so what that means, if it's of L from P, that means we are starting at P. Now, whenever you're answering a bearings question, you need to remember that you measure your bearing from the north, and they've been nice, they've drawn the north line on there for you. You always measure clockwise, and your answer always needs to have 3 figures in it. Okay, so we are measuring from the north. Now, you've only got a half circle protractor, so you've only got a 180-degree protractor. So what you need to do is you need to measure round, mark a line at 180, and then draw that in with your ruler. And if it helps you, show that that's 180. Okay, remember we want to get to L, so you're now going to take your protractor. So again, lining up the centre of your protractor, measuring from that line. Now I'm using the outside scale here because I have to line up my 0 line with the line that I've just drawn in. And if we measure round, it's looking like it's about 38. So it's another 38 degrees to add on. Okay, so to get my answer then, I'm going to do the 180, so my straight line, plus 38. Again, it is a calculator paper. Don't make a silly mistake. So your answer is going to be 218. It's already 3 digits, so you don't have to worry about that. Okay. From the lighthouse, Ben sails on a bearing of 320 degrees. He sails for 35 kilometres on this bearing to the port Q. And you need to mark the port Q with a cross and label it. The other key piece of information you've got here is you've got your scale. You're told that 1 centimetre represents 5 kilometres. Now, before you start drawing anything, it's worth working out your scale. So if we know that 1 centimetre is equal to 5 kilometres, 35 kilometres, okay, to get from 5 kilometres to 35 kilometres, we've multiplied by 7, so 7 centimetres is going to be 35 kilometres. So once you've measured your bearing, you need to remember that you're drawing a 7 centimetre line. Okay, so we are going from L, and we want a bearing of 320. So again, line up your protractor with the north line. Again, it's a bearing that is greater than 180, so I'm going to mark my 180 degrees line. And then from that line, I'm going to do 320 minus 180, which is going to give me 140. So from that line, I need to measure a bearing of 140 degrees. So again, lining up with the point L, using the outside scale, measuring round to 140, which is here. So I'm going to mark that in, and I need that line to be 7 centimetres long. So using your ruler, lining up 7 centimetres at that angle. Finishing off the question then, you need to mark it with a cross and label it Q. Okay, question number 9 then. So we've got a rectangular television screen with a width of 45 centimetres and a height of 34 centimetres. You're being asked to find the length of the diagonal of the screen. Now, normally, if you're asking an exam question to find the length of diagonal, it's kind of hidden Pythagoras' theorem. So straight away, you should be looking at a question like this and thinking Pythagoras. okay? Because we've got a right-angled triangle here made from the height and the width. So I'm going to write down Pythagoras' theorem, so I know that a squared plus b squared is equal to c squared. I'm then going to label my diagram correctly. Now, the important label is the fact that your diagonal is C. Remember, C always has to be the hypotenuse, the longest side of your triangle. A and B, it doesn't really matter. I'm going to label my 34 as A, my 45 as B. So I'm now just going to substitute into my formula. So 34 squared plus 45 squared is equal to C squared. Okay, then take my calculator. So I type in 34, find my x squared button, plus 45, find my x squared button again, press equals. Write down that answer so I know that 3,181 is equal to c squared. Now remember, I want the length of my diagonal. So if I know the length of my diagonal squared, in order to find the actual length of the diagonal, I need to take the square root. So the square root of 3,181 is equal to c. So again, take your calculator, square root button, 3,181. Okay, and you're getting the answer 56.40035 and a bit. Now you're asked to give your answer correct to the nearest centimetre. Correct to the nearest centimetre, that is going to be 56 centimetres, because remember we are looking at this value here. It's a 4, so we round down. Okay, so trial and improvement. Again, this is a question that you're pretty much guaranteed to get. And you know you can only get it on the calculator paper because you have to use a calculator for it. So again, it's one that it's worth being able to do. Okay, so you are told the equation x cubed minus x is equal to 30 has a solution between 3 and 4. Okay? Now you're asked to use trial and improvement method. So if you were to use any other method, even if you got the correct answer, you would get 0 marks. So this is the method and the working out that you have to use to get the marks in this question. So I'm going to set my answer out in the form of a table. So first of all, my first column is going to be x, because I'm going to show the different values of x that I'm trialling. Okay, my next column is going to be the equation itself. So x cubed minus x. And then I'm leaving a column blank for a comment, okay? Okay, now you're told that it's got a solution between 3 and 4. So a sensible place to start will be exactly halfway in between 3 and 4. So I'm going to try x is equal to 3.5. Okay, so I take my calculator. Now I need to type in 3.5. Then I find my x cubed button, because I want 3.5 cubed, minus x itself, so minus 3.5, press equals. Now again, if you are getting fractions, you need to press the SD button, because this needs to be in decimals, because you need to see how close to 30 you are. Okay, so I'm getting an answer of 39.375. Now remember, look back at your original equation. We want an answer of 30. So that's clearly too big. So if you write in your comment, too big. Now, because that's quite a long way away from our answer, it makes sense to try and answer a lot closer to 3. So I'm not going to try 3.5 because I can tell it's going to be too big. I'm going to try 3.3. So exactly the same method as before. 3.3. Press my cubed button, minus 3.3 equals, okay, 32.637. Now it's still too big, but it's a lot closer to where I want to be. So again, I'm going to write in too big. This time though, because it is close to the answer, I'm only going to drop down 1. So I'm going to drop down by 0.1 to try 3.2. Okay, So same as before, 3.2, press my cubed button, minus the 3.2. Again, you're getting a fraction, so we press our SD button. Okay, 29.568. Now this is really good news because this is too small. So that means we now know that our answer is somewhere in between 3.3 and 3.2. Now we're being asked to give our answer correct to one decimal place. So at this point we know that our answer is either going to be 3.3 or 3.2. What we need to do now is decide which one it is. So I'm going to try the middle of 3.2 and 3.3. So I'm going to try 3.25. Exactly the same as before. 3.25, press my cubed button, minus 3.25, press the equals. If you need to, press the SD button. You get an answer of 31.078 in a bit. Now that's too big, so that means I know that my answer is somewhere in between 3.2 and 3.25. Now if I'm giving an answer to one decimal place and I've got an answer that's somewhere in between 3.2 and 3.25, that means I'm going to round down, so my answer to one decimal place is 3.2.
Okay, question 11. Part A. M is an integer such that, and we've got -1, and then we've got a couple of inequalities there. So, things to remember. Integer is our posh maths word for just whole number. Okay, so we're not talking about decimals or fractions. We are only interested in just whole numbers here. And then what we've got is this inequality. I'm going to write it a little bit bigger. Okay, and we're trying to find out what possible numbers could that letter M be in the middle of those inequalities. And so, remember for the inequality, we've got -1, and it points to the small end. Okay, so -1 is less than or equal to M. If it's got that extra little line on, it is allowed to be the -1 as well. Then you look at the right-hand side and you've got M is less than 4. Okay, but it's not equal to 4, so it's not allowed to be 4. And you've got to come up with, well, what numbers could it be? Now, obviously, you've got the ones in the middle of -1 and 4. So the obvious choices would be things like 3, 2, 1, and 0. They're clearly in the middle of those two numbers. You just have to decide, is it allowed to be either of these two numbers as well? And because there's the extra equals on the -1 side, it can be -1 itself. And then we just basically list all of the whole numbers that it's allowed to be. So it can be -1, it can be 0, it can be 1, 2, 3. What it can't be then is 4, because the inequality on the 4 doesn't have that extra little equals line. So it's just a list, in this case, of 5 numbers. Part B, solve the inequality. Okay, again, there was a question, I think, like this last week. You solve an inequality in exactly the same way as you do an equation. Okay, we add, subtract, we balance it, but we just have to bear in mind that it's an inequality symbol, not an equals. But it behaves in the same way. So if we've got 3x and it's greater than or equal to x plus 7, okay, there's my question. What we're trying to find out then is what can x be? So like you would with an equation, find out what x equals. We're going to find out what x can potentially be as an inequality. So I'm looking at that, and I've got x's on both sides. So I want to try and take away some of those x's to make them disappear. So I've got 3x here and a 1x there. So what I'm going to do is take away 1x from both sides. Okay, just like you would with an equals and an equation. So 3x take away 1x gives us 2x over here. My inequality doesn't change, and that's the key bit. You keep that inequality facing the same way, doing the same thing. Don't flip it, don't turn it, keep it nice and secure in the middle there. X take away x, that then disappears. So I get left with just my 7 on this side. Okay, that's the whole reason why I took away 1x. You've then got 2x is greater than or equal to 7. But we want to know basically what 1x is. So the way I would get rid of that 2 would be divide by 2. Okay, and divide the other side by 2. But yet again, keep that inequality in exactly the same fashion. Same way, same symbols. 7 divided by 2, you've got two choices. You can leave it as the fraction, 7 divided by 2. Okay, you could also write it as the decimal, 3.5. Okay, both would be perfectly acceptable answers. Okay, so over on here, I'm going to leave it as the fraction, but you could put a little or, use your calculator and work out the decimal. Okay, both would be perfectly allowed. Part 2 for that question, it's now giving you a bit more specifics about what that x can be. X is a whole number. Write down the smallest value of x that satisfies the inequality. Okay, now the first thing to look and to spot is that inequality is exactly the same as the thing you've just done. So it's not like an additional question, it's an add-on to it. So we already have our answer to that previous question. Okay, we've already got that x is greater than, okay, and I'm going to use this one, is greater than or equal to 3.5. And then you just reread the question. X is a whole number. Okay, what is the smallest value that it can hold? So basically, you know that x has to be bigger or equal to 3.5, but you also know it's got to be a whole number. So the smallest whole number that fits that rule would be the number 4. Okay, 3 wouldn't work because 3 is too small. So you just go to the next whole number and see what fits the rule. Okay, question 12. Again, a very, very common question on the calculator paper. Okay, you get given a table of data. So we've got a table gives some information about the time taken by a group of 100 students to complete an IQ test. And it gives you that information in a grouped table. So we know that 12 people took somewhere between 60 and 70 seconds. Okay, and then so on. And you've been asked to estimate the mean. Okay, now traditionally to work out the mean, you add all the numbers up and divide by how many. The problem here is you genuinely don't know what these people got for their test score. Okay, you don't know what these 12 students got or how long it took them to complete the test. You know it took somewhere between 60 and 70. So this is where the word estimate comes from. We have to make an educated guess. Okay, and they normally leave a couple of spaces for some columns. So this extra column is our educated guess, and we call it the midpoint. Now I generally don't know, as I said before, what those 12 people got, but a sensible guess would be, well, because it's between 60 and 70, let's presume they all took 65 seconds. Okay, and that's where the estimate comes in. It's making that assumption. And you make that assumption throughout all the different groups. So these 22 people, somewhere between 70 and 80. So we pick the midpoint, 75. And quite often, they just go up in a regular pattern from there. 80 to 90 would be a midpoint of 85. 90 to 100 would be a midpoint of 95. And 100 to 110 would be a midpoint of 105. Okay. What we've then got to try and do is the adding them all up and dividing by how many part. Now, you've got 100 students there. So effectively, we need to try and add up 100 numbers and divide by 100. Now, there has to be a quicker way of doing that, otherwise it would take too long. So what we try and do is add on an extra column, okay? So just add on just one more column where we can do a few little calculations just to help. And so what this last column is going to be is trying to do that adding up part, but a lot quicker. Okay? We know that 12 students, we've estimated they took 65 seconds. So if we presume all of them took 65, we do the quick calculation of 12 times 65. Okay? And this becomes the frequency times midpoint column. Okay? And we do this calculation. So 12 times 65, 780. Okay, that's what those 12 numbers would add up to. And then we repeat the process for all of the different groups. So 22 students took 75 seconds. So 22 times 75, 1,650. And make sure you're writing all of these bits down as well. 23 students took 85. 1,955. 24 students took 95 seconds. 2,280. And the last one, 19 students took 105 seconds. $1,995. Okay. What that's helped us do then is quickly add up all of these different 100 students' results. So the last thing we need to write down is a couple of totals. We need the total frequency times midpoint. We need all of those numbers added together. So this is going to come from the 780 add 1,650. And basically those numbers in that end column. So if we carefully add those up, we should get 780, add 1,650, 1,955, 2,280, add 1,995. Okay, if we've done it correct, we should have got 8,660. That's the adding them all up part of the mean. You've then got the divide by how many. So the how many is always your total frequency. Now the shortcut is you read the question, because it normally tells you this number. The table gives information about a group of 100 students. So you know that this is talking about 100 students, okay? If you've misread it, or you forgot about that part, the total frequency would just be the addition of your frequency numbers. But we should find that they add up to 100 anyway. So we've got our two numbers. To work out the mean, we would do the 8,660 divided by the 100 students. Get rid of my fraction, and it gives us 86.6 seconds. Okay, again, don't round that. You do want the full value, 86.6. Sometimes they don't always give you that empty column. Sometimes they do just give you the first two, but they do give you a bit of space, and you might have to add those two columns in. But that would be the technique that would be needed. Okay, question 13. You're going to need your compass for this. Okay, compass and your ruler. So what we've got, the map shows part of a lake. In a competition for radio-controlled boats, a competitor has to steer a boat so that its path between A and B and C and D is a straight line. This path is always the same distance from A as from B. Okay, so it's not just any straight line between those two dotted ones. It's got to be the one that is exactly the same distance from A and B, okay? So we're looking at this line here, A and B, and what we need to do is what's called the perpendicular bisector, okay? Perpendicular being at 90 degrees, and then the bisector part being basically cut in half, okay? If you want to be the same distance from two things, you want to be exactly in the middle, so halfway between both. And the technique is quite simple. You just need your compass, okay? Hopefully you can see this. Put your compass point on either A or B, and the key bit is you just need to extend it over halfway. So try and aim for about 3/4. It doesn't matter if you're a little bit less than 3/4, a little bit more. You've just got to be over halfway. So over halfway, and what you want is a nice big kind of semicircle. So you make the arc. Do not move your compass once you've done that, as in don't move the distance between it. Keep it set. Put your point then on the other side, so on A. And you're just going to do exactly the same, but from the other side. So make sure it's nice and accurate from point A, and you want, again, just the opposite arc. So you should get, again, kind of an opposite semicircle. And then we should find that they cross. Okay, they should find that they cross in two places. If we now draw a line between those 2 points, so where they cross, there and there, that line is your perpendicular bisector. And what we want is the part then that goes right between the two dotted lines. So I'm going to draw very, very lightly for that first part of it, and then a bit stronger for that second part. But essentially it's one straight line all the way through. Okay, I've just shaded the bit in between the two dotted lines just a little bit stronger. Okay, what you do not want to do is rub any of that out. The marks for this come from the fact that you've done the curves. So if you've cleverly guessed it, or you've used your ruler to measure it in centimetres and millimetres, and you haven't got those two arcs, you will get nothing for it. So it is a technique, it is about the kind of construction technique. So they would be expecting those two arcs on there. The second part at the bottom then, there is a practice region for competitors. The practice region is that part of the lake that is less than 30 metres from E. Okay? And again, similar to our bearing question, the scale of the map is 1 centimetre to 10 metres. Okay? So the first thing before we draw anything is, if we've got a 30 metre, okay, we've got to show that something is less than 30 metres.